Okay, here we have another animal transport question. It's still homework time. I've still got all my stuff with me. Pen, pencil, calculator, ruler, highlighter. And this one again, pictures and a graph. So, what my diagram's showing me, they're showing me 3 different types of blood vessel. So I've got vein, capillary, artery, not drawn to the same scale. I could have probably worked that out. So artery, we've got this big thick wall. We've got the tunica externa and tunica media on there, and the lumen. And we've got here, we've got a thin wall, and we've got the externa media lumen again, and here we've just got one cell and a lumen. Okay, so question: give a characteristic of each blood vessel and explain how it's related to the function. So I want to do 2 things. I want to say what it is and what its function is. So, what do I know about veins? I could put veins have a large lumen. What do I know about them? So veins, these are going into the heart, so they're under low pressure, and this is arteries away, high, and these of course are exchange, so that's something I need to be talking about when I get to them. I have a large lumen, so as not to impede flow under low pressure. And the one thing I'm absolutely certain of is that they've got valves to prevent backflow. So they're not on the diagram. It doesn't say it has to be off the diagram. And I absolutely know that that's right. So one thing I can see off the diagram, one thing that I can't. So, capillary. Capillary is the next one. This is involved in exchange. So it's 1 cell thick, that's what I can tell off the diagram. To give a short diffusion path for exchange. And now I've got my artery. Artery, nice thick wall. I don't want to call it a wall, so I'm going to refer perhaps to the tunica media. So it's got a thick layer of muscle and elastic tissue. And why? Because it's under high pressure to withstand the high pressure. And elastic recoil. That's the thing I love about arteries, elastic recoil to maintain the pressure. Excellent. So that's that done. So now onto the graph. Yummy. So we've got blood pressure changes. Following diagram shows blood pressure changes as blood travels through one circuit. So this is talking about it going from the aorta around to the body, back to the heart, into the heart, up to the lungs and round. So what did we do in class? We said that that was pulsatile. Pulmonary, so we've got lower pressures. But same route through these things. And then we've got A and B. A, big spiky up and down in the aorta, and B going from the arterioles into the capillaries, going from pulsatile to laminar. So, explain fully, so I've got to give full reasons why the blood pressure goes up and down in region A. So region A is the aorta. The aorta leads directly out of the left ventricle. So the pressure in the aorta rises when blood enters as the ventricles contract. And drops as the ventricle relaxes. Now, that's only two things. I'm not even sure, it might just be one thing because of the rising and falling thing I'm only talking about. Right. So I need to perhaps talk about why it doesn't drop all the way down. Doesn't drop to zero because the semilunar valve's shut, keeps the blood in the vessels. And when the ventricles relax, to prevent backflow, just getting as much stuff in here as I can. What else could I talk about? I could potentially talk about elastic recoil. Elastic recoil maintains the pressure. So I'm not saying that elastic recoil is responsible for the up and down, that's the ventricles, but it keeps that pressure high. Okay, brill. So, why does the blood pressure decrease rapidly in region B? So here we're going from arteries to arterioles, region B. So this is just the idea that we're spreading that blood out. So arteries divide into arterioles with a larger total cross-sectional area. But narrower vessels with increased resistance. Slowing flow. So I'm pretty sure that I've got that one mark. I think I've said two different things there, so that's good. Okay, so Why is it important? Why is it important? The blood pressure in the lungs is lower than the body's. What do I know about blood pressure? So here I said about exchange, and I also know about capillaries that they do tissue fluid. So obviously fluid build-up in your lungs is not going to be a good thing. So okay, I'm going to go for that. So less tissue fluid because of blood pressure. To speed up, just thinking, speed up gas exchange. Just make it clear. I think the fluid would slow it down. Okay, job's good.